Hello, welcome to the webinar WDMA Product Category Rules, an introduction, usage, and guidelines for interior architectural doors and fenestration assemblies. The Window and Door Manufacturers Association provides quality programs to industry professionals for educational needs. WDMA is leading the way in elevating the discussion about advocacy and educational content for architects, specifiers, and builders, in addition to industry manufacturers and suppliers. Our goal is to produce meaningful educational tools to support members and those alike and become the go-to resource for the window, door, and skylight industry. The presentation is brought to you by WDMA. Founded in 1927, WDMA continues to pursue, advance, and explore the possibilities for window, patio door, entry door, skylight, and architectural doors, manufacturers and their suppliers and customers. The Window and Door Manufacturers Association promotes, protects, and advances the use of high-performance, high-quality windows, doors, and skylights through advocacy, education, standards, and certification. We hope you enjoy this learning session. The Window and Door Manufacturers Association is a registered provider of AIA-approved continuing education under provider number G346. All registered AIA CES providers must comply with the AIA standards for continuing education programs. Any questions or concerns about this provider or this learning program may be sent to AIA CES support email address or by calling the AIA. This learning program is registered with AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material of construction or any method or manner of handling, using, distributing, or dealing in any material or product. This AIA continuing education credit has been reviewed and approved by AIA CES. Learners must complete the entire learning program to receive continuing education credit. AIA continuing education learning units are earned upon completion of this course and will be reported to AIA CES for AIA members. Certificates of completion for both AIA members and non-AIA members are available upon request. For today's learning objectives, we'll take a look at an introduction and overview of product category rules and how they apply to interior architectural doors and fenestration products. This will include how to define PCRs, explaining the purpose of them, identifying key components, and applying their requirements in practice. In the second part of the presentation, we'll review the purpose and scoping of developing a life cycle assessment. This will include how data is collected and evaluated, identify common environmental impact categories, evaluate environmental trade-offs, and how to apply LCAs to products and services. The last part of this presentation will look at a foundational understanding of developing environmental product declarations. It'll be a review of the role in sustainability, transparency, and product claims. We'll also get an overview of how EPDs are used in green building programs and identify emerging regulatory issues. Overall, we'll take some time to understand the relationship between PCRs, LCAs, and EPDs, and how they apply to interior architectural doors and fenestration products. At the end of this session, you'll gain knowledge of each of these key topics and steps. First, let's look at some of the key terms that will be discussed during today's session. Much of the focus today will be discussion on these terms for product category rules, life cycle assessments, and environmental product declarations. These are more commonly known by their acronyms. Therefore, we'll regularly refer to them as such. But we'll also be sure to take a closer look at other terminology associated with developing these three documents. When developing standards, PCRs, LCAs, and EPDs, we'll reference performance requirements, green building standards, and other key documents and how they apply to these terms. First, let's take a look at product category rules. A general definition of a PCR are reports that specify the requirements for the review and comparison of different environmental attributes among products in a defined category. Comparisons are only valid within the same product category. So what does this mean? PCRs are standardized formal reports and rules that apply to a specific group of products. In this case, the session is focused on the defined categories of interior architectural doors and fenestration products. These rules define how products are grouped, managed, and governed within a category to ensure consistency and compliance. They also establish the category hierarchy, determine where products can be listed, and specify required attributes such as size, material, or technical specifications. PCRs help maintain data quality, customer trust, regulatory compliance, and scalable product management. PCRs don't just describe products, they set rules and criteria. It's these rules that govern how environmental information must be collected, calculated, and reported. These define mutual exclusivity and how products typically belong to one primary category, the limits of how many subcategory levels are allowed, and the naming conventions for standardization. PCRs enable the consistent evaluation of products that can be fairly compared because they follow the same methodological framework. This is the process of reviewing and validating products to ensure they are correctly classified and fully compliant with the rules of their assigned category. To capture all the data, a PCR is a report with the framework that includes evaluating carbon footprint, energy use, water consumption, emissions, and resource depletion. Products are reviewed to ensure claims are specific, accurate, and supported by credible evidence, avoiding vague or misleading statements. In all, PCRs define which attributes matter and how they should be measured. Other key points about PCRs that are important to know is that they are developed through a collaborative, multi-stakeholder process. These are participants who develop the PCR and the participants who provide the technical information and knowledge that contributes to the language in the document. The first are program operators. Program operators are the secretariat that manage the programs and participants and oversee the development, approval, and publication of PCRs to ensure consistency with international standards. They also provide the framework for how the PCR is written and formatted. Program operators are responsible for owning, governing, and maintaining the rules that define how products are classified and evaluated within a category. Their role includes designing and updating category requirements, such as mandatory attributes, compliance criteria, and sustainability or regulatory standards, and ensuring these rules align with business goals, legal obligations, and industry best practices. Last, program operators oversee the implementation and enforcement, ensuring that evaluation processes, tools, and audits are applied consistently across products. The second key participant are the industry stakeholders. These include manufacturers, industry associations such as WDMA, and technical experts from the relevant product category, such as doors and windows, that often contribute data, technical knowledge, and practical insights to ensure the PCR reflects real-world production processes. Other interested parties often contribute to a PCR, such as policymakers, users of the PCR, and customers. These interested parties provide feedback during public consultation phases to improve transparency and balance. WDMA develops and provides PCRs to members and users of the standard for two product categories: interior architectural doors and fenestration assemblies. These are current documents that are available for public use and by industry stakeholders to develop environmental product declarations. WDMA partners with program operators to develop the PCRs that are reviewed, updated, and renewed on a 5-year cycle. WDMA's architectural wood flush door standards are voluntary industry standards based upon generally accepted industry practices used to provide guidance to architects, designers, and specifiers to clearly identify the aesthetic and structural performance. This standard also describes the various functions and performance levels that are attributed based upon the wood door construction. This PCR document specifies rules, requirements, and guidelines for developing EPDs, for the underlying requirements of related lifecycle assessments. This PCR is valid for and provide requirements for business-to-business EPDs. The product group includes interior flush door leaves compliant with WDMA's industry standard for interior architectural wood flush doors and the industry standard for interior wood style and rail door leaves, which are both for use in commercial buildings. A few things to know about this PCR for interior architectural doors. This PCR documents the goal and scope of LCAs for this product category in order to produce EPDs according to ISO 21930. A quick note, an ISO stands for International Organization for Standardization, which is an independent, international, non-governmental organization that develops global standards to make sure products, services, and systems are safe, reliable, and consistent worldwide. In this case, the PCR for interior architectural doors references ISO 21930 for sustainability in building and civil engineering works. ISO 21930 defines how environmental data for construction products should be structured and reported so that it is consistent, comparable, and usable across projects and countries. It allows interior architectural door products from various manufacturers to be compared fairly. This PCR includes the life cycle phases in order to obtain the raw materials and manufacture of interior architectural doors. One note, this PCR excludes door leaves only used for single-family residential applications, exterior door systems, and doors made primarily from metal. The PCR for fenestration assemblies references a couple of primary standards for windows and energy: the North American Fenestration Standard and the ASHRAE Energy Standard for sites and buildings, except low-rise residential buildings. The North American Fenestration Standard is the primary performance standard in the US and Canada for windows, doors, and skylights. Developed jointly by AMA, WDMA, and CSA, it establishes uniform testing and performance requirements for structural strength, air leakage, water penetration resistance, operational durability, and, where applicable, forced entry resistance. It classifies products into performance categories such as residential, light commercial, commercial window, and architectural window with increasing performance demands. Widely referenced by North American building codes, it provides a consistent basis for product certification, code compliance, and objective comparison of fenestration products. The ASHRAE 90.1 Energy Standard for sites and buildings, except low-rise residential buildings. It's the primary energy efficiency standard for commercial buildings and high-rise residential buildings in North America. It establishes minimum requirements for the energy-efficient design, construction, and operation of building systems, including the building envelope, lighting, service water heating, and electrical power. Widely adopted by U.S. state codes and referenced internationally, it provides both prescriptive and performance-based compliance paths to reduce energy consumption and operating costs while maintaining occupant comfort. Updated on a regular cycle, the standard serves as the technical foundation for energy codes such as the International Energy Conservation Code. A few things to know about this PCR for fenestration assemblies. This PCR documents the goal and scope of LCAs for this product category in order to produce EPDs according to various ISO standards for labels and declarations. This PCR includes the life cycle phases in order to obtain the raw materials and manufacture of fenestration assemblies. This PCR only covers exterior grade, finished, and assembled fenestration assemblies. The product category rule process goes through 5 primary steps in its development and timeline. It starts with a search for a PCR, followed by the drafting of the PCR document, then goes through a public comment process, then an expert panel review of any comment received before it's finally published. Let's take a look at each of these steps. Businesses that want to develop their environmental product declarations, something we'll go into more detail later, will first have to search for a product category rule that fits the specific product they're manufacturing and want to create an EPD for. Remember, set rules and criteria that govern how environmental information must be collected, calculated, and reported. A business and manufacturer will first identify their scope to determine which product they plan on developing an EPD for. The second step is to appoint a program operator, which is an organization that develops, manages, and maintains PCRs used to create EPDs. The product category is defined between the manufacturer and program operator, who then sets the requirements for how the PCR will be developed. The next step in the PCR development process is to begin work on drafting the language of the document. A key aspect is to develop a definition for the product. For WDMA PCRs, the development process consisted of developing definitions of interior architectural doors and fenestration products. These are definitions that are developed and accepted by manufacturers in the respective industry. The program operator of the PCR will develop and describe the reporting requirements and verification rules, in addition to help the manufacturer with determining the EPD format requirements. As with the development of most product standards, after a draft has been completed, the standard is released for a specific period of time and open for comments from the public, which includes stakeholders and users of the PCR. This opens the dialogue to allow the program operator to engage with stakeholders who were not part of a working group developing the standard. Regardless, the public comment process allows for check and balances to ensure all information contained within is clear and fits the language used within the industry for the product. Comments are collected during the public comment period, reviewed and resolved. Last, the PCR is revised as necessary to reflect the stakeholder review. The fourth major step in the PCR development is the expert panel review. The panel is a group of experts who develop life cycle assessments, construction material specialists, sustainability and environmental science experts, and standards development experts. They review the public comments and revisions to ensure methodologies are accurate to allow the PCR to go through the final revision. After final revision, the panel approves the publication, then goes to the program operator for final approval. Last on the steps is the publication of the PCR. The PCR is published in a registry so that they can be searched and found by product manufacturers who are interested in developing an EPD. This will allow the PCR to be verified against new EPDs. The industry association, such as WDMA, will make the PCR available for purchase and use. Moments ago, we mentioned life cycle assessments. As it relates to product category rules, manufacturers will utilize life cycle analyses to help make decisions on environmental data as a means of measuring and reducing product carbon footprints. In essence, LCAs quantify and analyze the environmental impact of a product, including raw material acquisition, the manufacturing of the product, and its use from raw material extraction to end of life. LCAs help support sustainable product design, ensuring the material used for production can meet regulatory and sustainable declarations. LCAs also help compare materials and manufacturing processes. If choosing between one type of wood versus another, an LCA will help with allowing the comparison of the sustainability of each of those woods. LCAs also cover the life cycle stage of the building product. We'll go into that shortly, but it documents the various materials used in a product from the extraction of raw materials, though they're used in the manufacturing process and beyond. Last, an LCA can help with preventing misleading conclusions. If a specifier is choosing between two products in the same category, an LCA can help ensure that one that is using an LCA can back their claims on the sustainability practices. In the life cycle analyses development, the first step is the extraction of raw materials, which represents the very first stage of a product's life cycle. This phase is often referred to as cradle in cradle to gate or cradle to grave studies, and it sets the environmental baseline for everything that follows. It's the harvesting, extraction, or quarrying of materials that are used to develop parts and components that make up the final manufactured product. Second is the transport of the raw materials to a manufacturing facility for processing. For doors, windows, and skylights, there are several materials taken from extraction that make up the final product. For manufacturing, the glazing for windows, doors, and skylights is typically fabricated by a glass manufacturer. Likewise, the manufacture of other wood, metal, and sealant materials are provided by suppliers to window and door manufacturers for their use in the assembly of their products. This is considered intermediate manufacturing in order to produce the final manufactured product. These first three steps of an LCA are known as the cradle to gate, which evaluates the environmental impacts of a product from raw material extraction, the cradle, up to the point it leaves the factory, the gate. The delivery is the fourth step of the LCA development process. Manufactured products can exchange hands between various shipping and transportation companies from the manufacturer to the construction site and the end user. This is often a significant contributor to greenhouse gas emissions and is included in an LCA assessment. For this phase of an LCA, part of the life cycle assessment is the storage of building products until ready for installation. The last step of an LCA is the end of life. During the replacement of building products, or during the demolition of buildings, this considers the treatment after the product's useful life ends and includes reuse, recycling, energy recovery, and disposal. The PCRs developed by WDMA cover only the first three steps of the LCA development process of cradle to gate, or the extraction of raw materials to the manufacturing of the building product. They do not cover the entire cradle-to-grave process from extraction to end-of-life cycle. When an industry such as WDMA works with a program operator to develop a PCR, decisions are made to establish the scope of the life cycle assessment and its development. On this last part of the presentation, we'll talk about the last piece of the puzzle when ensuring building products accurately report their environmental impacts. An EPD is a Type 3 environmental declaration based on a quantified life cycle assessment that reports environmental impacts. It allows for the informed comparison between products under the same PCR. In order for a building product to provide credibility to the architect, specifier, building owner, and user of the product, an environmental product declaration is the report that does just that. EPDs provide transparency and credibility of a product. A business can make claims that a building product will perform a certain way, or that the raw materials used in the manufacturing are sustainable and environmental. However, those types of claims are difficult to provide credibility to unless an EPD is developed. Because of voluntary standards like LEED, EPDs are increasingly requested and are required in construction and by specifiers. Sustainable products are in demand, and EPDs help provide credibility. An EPD can provide market and competitive advantage. If a building product manufacturer develops an EPD and a specifier is comparing products in the same category, the specifier will at least have the opportunity to use it to confirm the claims on its environmental aspects. Last, an EPD can support participation in green building certifications. Of the voluntary certification programs that exist, an EPD can greatly help with achieving the certification. One example of a green building certification is LEED, or the Leadership in Energy and Environmental Design, which is developed by the U.S. Green Building Council. In 2025, the USGBC released LEED version 5 as an update to their last edition of the standard. This new edition of LEED is also designed to accelerate decarbonization while improving human health, resilience, and ecological outcomes across the built environment. It places a stronger emphasis and rewards measurable performance, particularly in operational carbon, embodied carbon, and climate resilience, while continuing to address energy efficiency, water use, materials, indoor environmental quality, and equity. It streamlines prerequisites and credits, aligns more closely with global climate goals, and integrates updated metrics, data transparency, and verification to ensure buildings deliver real-world environmental and social benefits over their full life cycle for use in whole building LCAs as a strategy. Last, it focuses on EPDs as part of the data infrastructure. If you're not familiar with the key differences between LEED version 4 and LEED version 5, the table on the screen helps with defining those significant differences. As you can see, EPDs and LCAs play a significant role in helping a building achieve LEED certification. LEED version 5 places emphasis on performance and carbon reduction and considers the whole building LCA as part of the core pathway to certification. Product comparisons through the use of a manufacturer's EPD is also strongly encouraged. Now that we've discussed product category rules, life cycle assessments, and environmental product declarations, let's talk about how all three of these documents work together and the relationship between. If a manufacturer of a building product such as windows, doors, or skylights has interest in developing their own environmental product declaration, the first step is to search for a PCR and determine whether a product category rule exists for their specific product. The second is to verify their LCA meets the requirements of the PCR. Third is for the manufacturer to compose their EPD. Next is to verify the PCR, LCA, and EPD through expert verification. The last is to publish all documents for use by various stakeholders. In all, this is an overview of the relationship between PCRs, LCAs, and EPDs. In all, PCRs define how to develop an LCA, ensuring fairness and consistency. LCAs produce all the scientific data that is used in EPDs, and EPDs inform comparisons between products in a category to communicate that the data is in a trusted, usable format. In short, a simple way to recall the relationship between all three documents is PCRs set the rules, LCAs do the math, and EPDs publish the verified results. We hope this presentation provided you with an informative introduction to the usage of product category rules and their usage. WDMA would like to thank you for attending this webinar. WDMA Product Category Rules: An Introduction, Usage, and Guidelines for Interior Architectural Doors and Fenestration Assemblies. This concludes the American Institute of Architects Continuing Education session portion of the course. You will have the opportunity to earn one AIA CES unit from the American Institutes of Architects by taking the course quiz. Upon completion and passing of the quiz, you will receive a certificate for your records. If you have any questions about this webinar or want to learn more about WDMA, you may contact WDMA via email at membersupport@wdma.com. Thank you.